This video is about expanding binomials using the FOIL method. In the previous video, we saw how an expression like x plus 2 times x plus 5 could be expanded using the area method. So just to recap, if we have an area that looks like this, we divide that area in 4. We have x plus 2 and x plus 5. And the area of each of these squares in the rectangle is found by multiplying the sides. X times x is x squared. We have 2 times x is 2x. We have x times 5 is 5x. And we have 2 times 5 is 10. I'll put a link to the previous video so that you can watch that. Now we're going to look at finding the expansion of this expression without having to use the rectangle. When you expand binomials, you end up with 4 terms. So if we complete this exercise, you'll have x squared plus 5x plus 2x plus 10. And we can collect the like terms. So we'll have x squared plus 5x plus 2x is 7x plus 10. And so when you first expand, you'll have 4 terms, and when you complete the expansion, you'll have 3 terms. This is the case in most expansions, but there are exceptions to that, and we'll see that in another video. These 4 terms in the original expansion are found by multiplying each of the terms in the first set of brackets by each of the terms in the second set of brackets. Let's take the same expression, x plus 2, x plus 5, and expand that using the FOIL method. So that's without having to draw the area. So let's for a moment pretend that the plus 2 is not in this expression. So we're going to multiply the x by each of the terms in the second set of brackets. So x times the first term, x times x, is x squared. And we'll multiply the x by the second term in the second set of brackets. So x times 5 is 5x. Now we're going to forget that the x is there, and we'll multiply the 2 by each expression in the second set of brackets. So 2 times x is 2x, and then 2 times the second term, 2 times 5 is 10. And we have the same expression now that we had when we expanded using the area method. And then we can collect our like terms as we did before, and so we'll have x squared plus 7x plus 10. Now, if you have a look at the set of arrows here, we've multiplied the first term in the first set of brackets by the first term in the second set of brackets. And then we've multiplied the first term by the last term, so that's the outside set of brackets. And then we've multiplied the inside set of terms, the 2 times the x, and then the last set of terms, the 2 times the 5. And so this is where we get the idea of FOIL. First, outside, inside, last. So let's look at doing another expression using FOIL. Let's do x plus 3 times x plus 2. So first, x is the first term in the first set of brackets times x is the first term in the second set of brackets, x times x is x squared. The outside terms, x times plus 2 is 2x. The inside set of terms, 3 times x is 3x. And the last set of terms, 3 times 2 is 6. Now all we need to do is collect our like terms, and so we have x squared plus 2x plus 3x is 5x plus 6. So first two terms in the sets of brackets, outside two terms in the set of brackets, inside two terms in the set of brackets, last two terms in the set of brackets. Let's have a look at some more examples. And each time we do an example, we'll get slightly more complex. Our first example, x plus 1 times x plus 4. First two terms, x times x is x squared. Outside terms, x times 4, 4x. Inside terms, 1 times x, 1x. Last two terms, 1 times 4, 4. Each time we're doing this, we're multiplying the terms together. Collecting our like terms, we have x squared plus 5x plus 4. So don't forget, first, outside, inside, last. Now let's start to make our examples a little bit more difficult. So x plus 5 times x minus 2. We'll start introducing some negatives. Remember that when you're using negatives, it's a good idea to highlight the term with a negative, and so that you don't forget that it's there. So we're going to highlight the negative 2. So we have first, x times x is x squared. Outside, x times negative 2 is negative 2x. Inside, 5 times x is 5x. And last, 5 times negative 2 is negative 10. This is where a lot of people get confused as to what to do next. So because we've introduced the negative with the 2, so negative 2x. It's probably best if you think about what would happen if I had a negative 2 and a plus 5. So negative 2 plus 5 will give me 3. And so negative 2x plus 5x will give me 3x. So I'll have x squared plus 3x minus 10. Let's look at what happens if I have two negatives in the question. So x minus 2, x minus 6. First of all, I'm going to highlight my negatives, a minus 2 here and a minus 6 here. So first, x times x is x squared. Outside, 6 times minus 6 is minus 6x. Inside, minus 2 times x is minus 2x. Last, minus 2 times minus 6. A negative times a negative is a positive, and so I have plus 12. Collecting my like terms, x squared minus 6x minus 2x, that gives us minus 8x plus 12. Sometimes the expression you have has the negative before the x, so let's have a look at what happens then. We still do first, outside, inside, last. We're going to highlight our negative, so the negative this time is belonging to the x. First, 3 times x is 3x. Outside, 3 times 2 is 6. Inside, negative x times x is negative x squared. Negative x times plus 2, the last terms, is negative 2x. And the interesting thing about this example is that our terms have ended up in a different order. When you write the final expression, it's best if you can put the x squared term first. So negative x squared is first. Collecting our like terms, we have plus 3x minus 2x. 3 minus 2 is 1, so that will be plus x, because we don't write the 1 when the coefficient of x is 1, we just write x, and then our plus 6. Sometimes your expressions within the brackets will have coefficients. So let's have a look at 2x plus 4 times 3x minus 2. This is probably one of the more complex examples that you'll see. So this will be our last example for this video. So once again, first, outside, inside, last. Our first two terms are 2x and 3x. 2x times 3x is 6x squared. Our outside terms, 2x times minus 2 is minus 4x. Inside terms, 4 times 3x is 12x. And our last terms, 4 times minus 2 is minus 8. Now when we collect our like terms, just make sure that you take note of where the positives and negatives are. Minus 4x plus 12x is plus 8x. This is where a lot of people get into trouble with these sorts of expressions. So make sure that you practice examples where you have negatives and positives so that you can make sure that you understand how these work. Sometimes it's useful to think about the number line and think about minus 4 plus 12, which gives you plus 8. And then our last term is the minus 8.